Okay, lesson number 10, implementing network security appliances. Yes, the last lesson we have discussed about the network architecture, secure network architecture. Last lesson we have seen about network security architecture and how we can have a secure network. And in this lesson, we'll be discussing about various security appliances that we can use in a network to have a proper architecture. The objective that we're going to cover in this topic is we will be discussing about the firewalls and the proxy servers and all. So implementing secure network design. So for implementing secure network design, we have firewalls. We know about firewall. Firewall is one of the longest serving type of network security device that we have seen so far, right? Developed specially for segregating the traffic, that is we can allow it or disallow it. And we have different types of firewall in the market. Especially we have packet filtering firewall here. In all the firewalls we have this access control list. Okay, we have to enforce it in the network, we have to enforce it in the firewall, to deny, to allow, to accept the traffic, to log it, the traffic, everything we need access control list. And we'll be inspecting the headers of each individual package in the packet filtering firewall. Especially it is actually a stateless firewall, okay, where it will not validate or where it will not check for the session, okay, with what's going on in the session, what's the communication happening. No, this is the stateless firewall that it will not check the session and it will not have any history about the previous packet also. And it inspect each and individual packet, and what it will check: source, destination IP address, protocol type, okay, and source and destination port numbers, and inbound outbound traffic depends on our rule or maybe both. Okay, so specifically it will check the packets, so it will be easy for the security team to understand what is incoming, what is outgoing. Ingress and egress traffic, we say it like inbound outbound traffic, you can easily filter it using access control list and the packet filtering firewall. And we have stateful inspection firewall. What is this stateful inspection firewall is? This one verifies or tracks the information about the session established between two hosts or blocking malicious attempts. Okay, and if anyone is trying to create a bogus connection, bogus session, it will check it and it will block it. Okay, now almost all these days no one, like it is in use, the packet filtering firewall is in use, but majority people start using the stateful inspection firewalls. And in the transport layer, this is where the TCP handshake happens, and it holds information about the established and the new connection also in the transport layer. In the application layer also it works, where it validates the protocol, it matches the thread signatures, someone is trying to give payload or input something, and unwanted commands, okay, or application specific filtering, for example FTP commands, HTTP commands, specifically what the user or the attacker is trying to pass it to the victim machine or victim network, that is our network. So we can easily inspect it using this firewall. And we have this IP tables. IP tables is actually a command line utility that runs in Linux distributions. So administrators can edit the rules for allowing and disallowing, for dropping, for accepting the connection, and they can easily configure the source port also, the source IP address, destination port, and the destination IP also, and the protocol type also. So this is how the command will look like. IP table, input the protocol with the source IP and the destination port. If it comes, then it should accept. Okay, otherwise from this particular source IP only, from the source network, actually they have mentioned the whole subnet. If it comes from any other network, if you have a configured rule, access control list to drop that particular traffic, it will drop it. Okay, and we have firewall implementation. So the firewalls are different types, and how we're going to implement the firewall. Okay, especially firewall are of two types, we know, one is hardware and one is software. So how we're going to implement it, and what is the proper implementation technique according to the design and all. Firewall can be placed inside or outside the network, depend on our need. Okay, so if you have more incoming traffic, okay, so place it outside, and means everyone will start communicating with you, so they will have the traffic filtered and you will get it. Okay, and if you have more outgoing, place it inside, so whatever you pass it will get filtered and then only it will pass. Okay, Then this firewall application, we can place it according to these three methods. We have routed method, bridged method, and we have this router firewall type. So what is this routed method? Between subnet, when you have a very big network, when you are trying to inspect the traffic between two different subnets, so you go for the routed firewalls. And what is this bridged firewall is? This is between the router and the switch. Okay, so outside the subnet you can place it. This bridged or transport firewall. What about router firewall? The single device will act as both as a router and as a firewall. Also, we have seen yesterday Soho firewall, right? So exactly the same one. It is a combination of both. It will do the routing also, and it will do the filtering action also. And we have application based firewall, that is the host based firewall. So for a particular machine, for a particular operating system, okay, you can have this particular host based firewall personally. And we have this application firewall that we will be placing just before the web application or web server. Specifically, the main purpose of that firewall is to block or to inspect the web application traffic, the application traffic that it is receiving or it is passing. Okay. So the web server firewall will definitely, it is actually a type of host-based firewall only. Okay, and you can add it or you can deploy it along with the network firewall also. With the hardware appliance also, you can deploy a computer and you can deploy this application firewall in that. Yeah, application firewall also comes separately as a hardware. You can have a software also, you can have open source also, you can deploy that also. So just we have to make the proper access control list. And what is this network operating system? See, when we have a dedicated firewall, specially made firewall, maybe a hardware or software, we can have it in the network according to our need. But this network operating system firewall, you can deploy a Windows based or Linux based machine. We want that to be acting as a firewall in a network or a gateway in the middle. So we can route all the traffic through that machine and then it will go to the other subnet or to the other network. Okay. So that is what network operating system firewall is. Simply, you can deploy it by yourself. And if you know. Okay. And what our access control lists are, and we were using this access control list from very first, and where we use it and how it is really working. The main purpose of this access control list to give the least access, means with the least privileges. Only who have privilege to access, only who have privilege to enter or to pass through the traffic or to gain the traffic, they can only access. That is the reason we have this access control list. And it is actually a top to bottom processing order. What is this top to bottom processing order is? You can see this picture where we have multiple access control lists added. Okay. So it will, if whenever a traffic comes, it will just verify the first, and then it goes, if that doesn't match, it will go to the next. Okay. And if that doesn't match, it will go to the next. Like that, it will proceed. Okay. That's how it goes until it will go, keep on, it will go in. And what is this implicit deny? In case, if you don't have any rule matching with the all access control list, okay, the last rule that you will have is implicit deny. Okay, means fully stop it. If any rule is not matching with the incoming traffic, you can make the traffic, or you can make the access control list to allow. So if any traffic that comes that's not matching with any of your rules, so you can deny it by adding this implicit deny rule. The name is implicit deny. So you will just, at last, you will block all the traffic. What is this explicit deny all means? Okay, there is no implicit deny all rule. So you can make, administrator can make a separate rule for dropping a particular request or for a particular user or for particular groups also. That is what explicit deny all traffic is. Okay. And criteria for rules. So on what basis we make this access control list? We make it according to tuples. So the criteria for rules, like on what basis we make this rules? So based on tuples that are parameters. So the columns you can see, those are all parameters, the protocol, source IP, port, destination IP. Okay. And what about the description? Like if you can add a particular description also. And gateway, do we have any gateway? If that comes from the gateway, so queue is nothing. It's the order actually we have. Normally we don't have that. Okay. So we make access control list according to the rules. We make access control list according to the parameters, and we'll have the documentation part and testing the configuration also we have to do once we make the access control list. Okay. And what is this network address translation? Yeah, we use this network address translation. That is how we free up our IP scarcity. Okay. So IPv4 is very limited, and if we are using everyone is having at least 3 or 4 IP address individually these days. A computer and a mobile phone, 2 mobile phones maybe, and a TV, we have smart devices. So we use lots of IP addresses. So we are running out of IP. So avoid, if no one can get public IP directly, static IP. So we go for NAT here. So NAT will mitigate this issue by creating a private network. See how you're getting private IP from the public IP. That's what NAT is working. But there is a small difference between the NAT in here. Just one more difference in here between the NAT. So normally the network address translation happens from your router to the internal network. Okay, this is your normal network address port translation or port address translation or overload NAT. Both, all the 3 names are same. So how this particular NAT works? How this NAT works? So what is happening really between the public IP and the private IP? So we have 100, or at least not 100. We'll take it as 3 or 5 PCs are together. Okay, and we're going to request a website from a web server. Okay, everyone is requesting the same thing. All 5 of us are requesting the same thing. Okay, and how really this router identifies the same thing, the request, and how it is giving us the exact page. So when we request, the DHCP and the router will have the functionalities to allot us the IP. It gave the IP. So when you do request, it will go to the router. Okay, and there it will have the table where it stores your port number from where you're making request and your IP address. Okay, then from the router, okay, it will make the request to the concerned web server that I need this particular web page. Okay, so when the web page comes, what this router will do, it will check the pages, the request, okay, and the port number that it needs to deliver, and it will deliver to the concerned IP address in the ports by inserting the original IP address and port number to the packets. Okay, and then it will forward it to the internal host, the 3 machines or 5 machines, whatever, like how many machines we have, it will just give it to them. Okay, that's how the conversation happened between public IP and the private IP. Now, what is this destination NAT or port forwarding is? This additional functionality we have is to advertise any of your local IP address in public, in global. How you can forward your port. Okay, you are deploying your web server in your Apache server or in your local host. You can use XAMPP, you can use LAMP, WAMP, whatever. So but it is good for your your local usage, but how it can be taken outside. So we need this port forwarding. When you're deploying some service in a particular port, you need to forward that port publicly. So you have to do it in the router. There is an option for port forwarding. So when you do have access to the router only, then only you can do. If you belong to a company and you cannot do this thing, and because you need access for the router, then you can do port forwarding. So in this, you will do forward a particular port where you deployed your service, and that particular port will be available outside. So if anyone is trying to access your site, they can access it. And there are several techniques these days. This is a basic concept how this private IP can be made into public, accessible in public. Okay, but we have the noip.com, we have ngrok, okay, we have the dynamic DNS. These are all the services available online to make all things possible very easily. You will just register with them. They will give you a client and install the client, and the client will take care of the rest. So it will automatically, we can use it. They will give you a host name instead of a URL, instead of IP address and port number. Okay, so if you want, like, it is not in here, note it down. If you want ngrok and noip.com DDNS if you type, or okay, so so that's what network address translation is. Then we have virtual firewalls. Yes, so it is actually, we don't call it as virtual firewall. We need the interface and everything and all, but the deployment method would be like slightly different from the normal ones. Okay, how? usually we deploy it in the data centers and cloud services where we have multiple devices to intercept, or where you have multiple traffic to monitor. Okay, first one is hypervisor based. So in this hypervisor based, we will install this particular firewall into the hypervisor or a cloud service, and your traffic, whatever that goes through that. Okay, for traffic to arrive or leave virtual host or virtual network, we use that by using APIs. Okay, we have to, if you are deploying your firewall in the cloud and you want to use your traffic to route through that, so you have to use cloud's API. Okay, then it is possible with the hypervisor method. And in virtual appliance method, it is deployed as a virtual machine to the cloud. Means, okay, you can think like this, like I want to deploy a firewall, but I'm running out of systems. I have to use it in my virtual machine. Means I can run a Linux or Windows machine in my single computer, then I will use it. So I will deploy a virtual machine through that, but I need to do routing so that all the traffic goes through that. Any vendor appliances, any vendor firewall appliance you can use. Okay, and we have multiple contexts. What is this? A firewall appliance, any appliance firewall you can use in a hardware also, in a software firewall also. You can have separate interface or separate network, and you can run it at the same time. Okay, multiple virtual firewall instances can be deployed in a single hardware firewall appliance. Okay, and how the traffic should go, it should be east-west in the security design and the micro segmentation. The reason is east-west security design and micro segmentation. Means the reason is, of course, if we have every networks or every segmentation, every firewall servers deployed in the same line, it is good if we have it in the east-to-west security design, because we have the north to south for the traffic that incomes. Okay, but if you are using the firewall for monitoring the internal network, so we have to go for east-west traffic security design. And we have this firewalls, open source versus proprietary firewalls. So yeah, we have in here open source versus proprietary firewalls. So what are these? We have discussed about standalone, application based or hardware based and all, but how we're going to buy it and what are the things? Yes, we have the proprietary firewalls, Juniper, Palo Alto, all these are proprietary firewalls, and pfSense is an open source one, and few firewalls run on Unix or Linux kernel with some proprietary feature. Example is FortiGate. So they have their own proprietary operating systems. Okay, but FortiGate uses Unix or Linux kernel with proprietary features in it. Okay, and of course we'll be needing the subscription, and we need support from them, so we have to use it accordingly with our needs. That is what the firewall, how we can do deploy, where we can get it. And yet, yes, we're going to discuss one more also. I think the next one we're going to discuss about that. No, in here only, in this lesson only, we'll be discussing that about UTM. What is UTM and all? Okay, so we've discussed about firewalls. How we're going to implement the network security monitoring? Is firewall is enough for us? And what are all the other devices that we can deploy? That's what we're going to discuss in this particular topic. So network-based intrusion detection system. So very simply, I'll let you understand. Intrusion detection system, IDS, is there. There are two types, network-based or host-based. If you're trying to detect whatever, first of all, let me explain what is intrusion detection system is. Intrusion detection system detects the incoming traffic exactly like firewall, but a bit smarter. Okay, how it will work, or it will check on the basis of patterns. Okay, how the traffic comes, how the traffic goes, where it goes. So everything it will check. A kind of intelligence added to firewall, how it will behave. That is what intrusion detection system is. Okay, so based on your need, you can deploy it in the network or on the host itself. When you are trying to intercept or when you are trying to monitor the whole network traffic, you will be needing network based. When you try to monitor only on the host, you need host based. That's it. Okay, multiple vendors are there. The Kibana is one for them, and if you want to use free IDS, you can go for Snort. Snort is actually a command line utility. There are lots of configuration we need to do. Snort is a free open source one. You can, if you want to try, you can download from the internet. And network sensor is the one that captures the traffic, and it will perform real-time analysis of indicators. What indicators? Indicators of compromise. It will check that if it detects anything suspicious that is malicious, that may create harm for our network, So that is how it detects, and it also do logging, and it also do alerting. It will not stop. It won't stop the traffic. It won't stop the packets. It will simply create alert. That is what IDS does. And what are these tabs and port monitors are? Yes, the packet capture sensor, especially in the IDS, needs to be properly placed. Based on the need, we can place it inside the firewall. Means, see, you in a network, you need to have your computers are on the left side, and you can have IDS next, and you can have firewall next, then you can have router. Okay, then it goes to internet. So you can place in this method also, or you can place it outside the firewall also. Okay, why? What is the reason of placing inside the firewall or outside the firewall is, if any incoming traffic that comes through router and then firewall, so automatically the firewall will block almost all the traffic according to the firewall rules. Okay, so almost your traffic has been 50% filtered. Then it comes into IDS. You had an extra security over there. You have an extra security over there when you place it inside the firewall. Okay, it's not mandatory you have to place it inside the firewall only. You can place it outside also. Okay, and you can place it in front of application servers. And this one, it simply manages the volume of traffic and it will create alerts accordingly. And what is this switch port analyzer is? Yeah, sensors do different types of works. When we do have switch port analyzer, or we call it as mirror port also. So the sensor we have in the IDS will do lots of activities. So one of that is the switch port analyzer. What it will do create or get attached to a specially configured port on the switch. Okay, when it happens, it will do copy the physical copies of the data that flows. Okay, maybe you can say that it can target one or two or port, like specific ports. That is also possible. Or if you want to copy all the ports, want to monitor all the ports, yes, that is also possible. Switch port analyzer will analyze the ports by copying the packet. Okay. And what is this passive test access point? This one is actually a kind of it will do in the with the ports only. This is also monitored with the ports for incoming and outgoing traffics. Okay, but the thing is, it copies the signal, okay, from the cabling, and it will send it to a monitor port. Okay, from the cabling, it will not copy the packets, it will copy the signals. Okay, and the functionalities are there, spectrum analyzing and all these techniques are there, and in the backend, the IDS will check what's happening. But you have two methods in here, active tap and aggregation tap. There are chances that you will lose packets in here, and it needs power source batteries, external batteries for it. Okay, for this analyzing of signals and the capturing of signals and all. Okay, regeneration is, it will do regeneration of signals if there is any loss, but it will not be a complete one. You won't be having proper packets at the end. Okay, that's the drawback with this passive test access pointers. But switch port analyzer are most preferable, because IDS can get a copy of exact packet and it can analyze easily. Then we have IPS. Yes, IDS does its job. It detected the traffic and it created an alert also. So who will block it? So IPS is the one that blocks the malicious traffic. Okay, intrusion prevention system. It give response, active response to the threats or the alerts created by the IDS. So if anything seems suspicious, it will reset the connection. It will apply firewall filters on the move to avoid such kind of traffic, bandwidth throttling. Okay, if you have DOS attacks. Okay, packet modification. If anyone is doing packet modification, it will detect that also and it will block it. And it uses scripts and or other processes to block such kind of malicious activity. Okay, but you can say how, like this run a script or other process and all, it can use antivirus scanning or it can use content filtering. Yeah, you can have a question here. It is an IPS prevention system. How we may have antivirus or content filtering techniques are in here. I'll let you know. That's why, like I said, like we have few devices yet to come about like UTM and all. So next generation firewall and all. So when we learn about it, you'll get to know. Okay, so all these things work together, and when you have everything in line, you have the server. Okay, you have firewall, you have IDS, you have IPS. Okay, so when you have all these things in line, the chances are there with the network that it may lose packets, or even if single point of failure, If any device or if IPS is not responding, if anything is not working, the whole line of network will not work properly, or it will be a total damage. So nothing will not work fine. Yeah, traffic will flow, but the efficiency, the effectiveness of the network architecture, secure architecture, okay, so placing inline is a bit disadvantage with the network prevention, intrusion prevention system. So how this really works, like I said, IDS and IPS. So yeah, this one, okay, we will be, so what's happening really with the signature based detection and all. See, this is what are the alerts that it will create. This is how it will look like when alerts has been created. Okay, so okay, so we have this signature based detection. It matches the patterns. You'll be having a database known for attack signatures. Whatever the attacks happened so far, whatever the patterns that we have researchers have found, we'll have the application will have the database for that signatures, and we have to update it with the latest definitions. Okay, plugins, people say it in different according to their tools, plugins, feeds, different ones. Okay, signatures, rules. Snort uses this word rules. Okay, so you have different definitions. You have to update it, and still many attack tools do not conform to the specific signatures. Okay, if some attacker is creating its own tool, okay, with the proper coding, okay, with a proper block of codes, so there are chances if you don't update your IDS, or if your IDS is not that robust, so IDS and IPS, so definitely it will miss those signatures. And behavioral and anomaly based detection, yes, that's how it works. Not what are all the behavioral and anomaly based detection it will do. Train sensor with baseline normal behavior to recognize anomalous behavior, means how you will do work. What kind of traffic you will do pass outside the network, or what kind of traffic that you will be receiving. Okay, so it will be there. You have to, your network administrator, your organization knows what kind of business you're dealing with. So based on that, you'll have a baseline behavior, and with that, by comparing with that, we can recognize the anomalous behavior. Okay, and network behavior and anomaly detection. What is this one is? Okay, I have my clients all based in South Asian countries and maybe from European countries, but suddenly my traffics are coming from strange IPs like in China and Russia. So network behavior is getting changed. Okay, so IP address is getting changed. So based on that also we can detect it. Okay, and of course we'll be learning from the experience. So if any attack happened, we will take that also into account in statistical model of behavior. So previously how it happened, what's happening. Okay, so everything we will be considering in detection, in designing the rules, and we will indulge the machine learning also. Okay, network traffic analysis, user and entity behavior analysis with the machine learning and artificial intelligence. Then this particular rules will be made. You know, almost in all the conditions, the vendors will be giving you the support for creation of the rules. So you won't be deploying anything if you have a machine learning expert. So definitely, what are the entity behavior, what are the user entity here parameters such as ports and everything. So for a particular user, how he is working, where he is working, based on that only we can create. Okay, and what about the network traffic and that also. Okay, and is there any irregularities in packet construction? What about this point? Anomaly based detection as irregularities in packet construction means when the traffic comes in from the attacker's end. Okay, attackers has tendency to play with packets a lot. Okay, they will do play with time to live values. They will do play with reassembly techniques. Okay, that is packet construction techniques. They will delay the construction. Why? These are all the IDS firewall bypassing techniques that attackers use. How? If I know that packets that I sent is getting reconstructed on the IDS and the IPS on the firewall within 20 seconds, all the packets or whatever I share, it will just do construct in the 20 seconds, and everything is getting accumulated. Then it is getting scanned, and then it is monitored, and then it is passed to the host machine, the other end machine. So he can change this kind of time to live value or the construction time, everything, and he will try to bypass it. So to defeat that, we should have the anomaly based detection, okay, to find out the irregularities, okay, on packet construction. For example, one packet reached me at 10 seconds. Okay, so if it is the usual time, I should receive the next packet at 10 seconds, but the attacker will plan it to send it after 15 seconds. So after 20 seconds. So the packet construction will get affected over there. So I have to check out this irregularity, means the IDS needs to check out this irregularity. So for that, we can create a rule. So that's what anomaly based detection. Okay. Then we have next generation firewalls and content filters. Yes. So the IPS that we have seen, right? What is this next generation firewall? Next generation firewall and this UTM is like more or like the same. Okay. So what is this next generation firewall is? It is application aware filtering. Okay. And it use user account based filtering who's trying to access, and it is having IPS in it and cloud inspection also. Okay. Along with that, we have lots of things added together to form the UTM, Unified Threat Management, a single agent, a single device where it can do everything. Okay. It can act as a router. It can act as a switch also, firewall, anti-malware. Okay. IPS, IDS, filtering. Okay. Data loss prevention, VPN, access gateway, everything. It will work. It's a single device that you can place. Okay, but very expensive. But if you are, instead of going with multiple devices, you can have one single device that can do all its work. Okay, and we have content or URL filter. Yes, focus on the URLs for outgoing traffic, content block list or allow list, time-based restriction when you can use it, or secure web gateway you can use it. Okay, secure web gateway also you can use for accessing any particular website or anything, particularly for web application. Okay, for web traffics you can use it. Okay, so it is a kind of content filters, especially for blocking some contents. Yeah, we use it normally. We use it in our organization, right, to block some basic websites or any entertainment websites. We used to block it. Same kind of method. We can use it a separate gateway to block all the unwanted traffics that goes out or comes in. Okay, and we have this host-based intrusion detection. Like I said, it's the same where you use it for network, that is network-based intrusion detection. When you use it for host, you have host-based intrusion detection system. The one advantage you have over the network-based intrusion detection system is the file integrity monitoring. Okay, what it will do, it will check for the integrity of files. Okay, whether it has been modified or not. Okay, it will check compare the hashes, and it will do work on it. Windows file protection. Okay, we have different methods like tripwire. Okay, different methods are there. We have over host-based intrusion detection system. So what is this like file system checker? Okay, and the tripwire and all. The tripwire and OSSSec, these are all actually examples of platforms, multi-platform tools that you can use to protect wide range of applications. If you want to use, you can use it. Okay, of course, it will be having subscriptions, so we have to pay for it to have our files secure. And I think we'll be having few more important slides. Yes. Okay, I'll explain the file integrity part, or what we need to do, monitor the files also, in last 2 slides of this session. Okay, we have web application firewalls specifically to inspect code in the HTTP packets. Whatever the request, whatever the response goes through web application firewall that matches to suspicious code to the vulnerability database it has, it will detect, it will block the attacks. So if I want to hack a web application, if I want to hack a website, okay, so what I will do, I will simply just run few commands. Okay, so this is a command. If I just click on hello, it will redirect me to bing.com or any other site. See, so this is what called as HTML injection is. Normal HTML injection is. So if I just click on it, it will redirect me to bing.com. Or if I just create some script in the internal field, I can get the cookie details. Okay, what is in cookie? I don't have anything in the cookie, so it just showing empty. If I log in, I will have the cookie details. So these kind of attacks can be performed easily by the attackers on a web server. If they don't have a web application firewall, what happens? It directly hits the server. So that's the reason when we have web application firewall, all the traffic will first go to the web application firewall. It verifies with the patterns, it verifies with the code that you are using, and it will try to defeat there itself. Okay, then it will pass it to the web server, your request. Okay, that is what web application firewalls are. Got it? Then we have this, and summarize the use of SIM. So what is this SIM is, and where we use it, and in our work profile where it really fits. Okay, and what is the profile if I do get to know about same if I'm searching for jobs. So I'll add that extra point also. So in this particular topic, we will discuss about the techniques used in security assessment, okay, and the network designs, and we'll have the tool that we use, or the technique that we use for in the organizational security. So in monitoring the services, we have the technique packet capture. We do that sniffers, okay, flow analysis, traffic and protocol statistics, packet analysis we have to do for monitoring. In the network monitoring, appliance state data, okay, that is appliance here says firewall, IDS, IPS, all. We need to check that one, okay. And what this heartbeat availability monitoring is, okay. So what is this heartbeat availability monitoring is? When we share a packet, when we share the traffic, okay, you can say, I can say it, 1 second, let me choose a live example. Okay, let's have the example live. Okay, so we have the data that gets collected in your various devices, network appliances, such as it comes with switches, it comes through access point, routers, firewalls, and all. Okay, and this is used to monitor load also on the CPU memory, disk capacity, what's happening. Okay, and the function that heartbeat message, the function that heartbeat availability in the monitoring is that indicates the availability of your resources, okay, with the traffic that you're receiving. Means if there is any heavy load comes, okay, we have to properly monitor it, okay, before it affects your internal devices that we discussed, like routers, access point, firewalls, and all. Okay, so we will be doing the network monitors first, then logs, system logs to diagnose the availability issues. So in case if anything happen, so we'll have to monitor, audit the system logs and the security logs to audit access. Okay, what happened, who tried to access, and where that comes from. Everything system security logs needs to be monitored. So everything we have to perform in the system monitoring, okay, or in the network monitoring. So again, in here, this is where the topic really means security information and event management. Okay, so this is when we have multiple data traffic, right, that comes into the network. Okay, we have to check the availability. Heartbeat availability means we have to check the devices are healthy enough to withstand any kind of high range net attacks. Okay, disk space, state tables, CPU memory, everything. Okay, so we have to do check for the heartbeat availability. Simply you can say it is healthy or not. They've used the term heartbeat availability to indicate the availability of the devices with the traffic that you are receiving daily or regularly. If you're receiving more, so you can indicate that something is happening fishy, so you have to take mitigation steps. So what is this security information and event management, also called as SIEM, SIEM? Okay, the SIEM really fits with the profile incident responders and the SOC analyst, okay, security operations center analyst profile. Okay, so this particular SIEM tool is to specially aggregate the traffic data and logs. Log aggregation and collection, this is what the complete work of this tool. Okay, this tool won't be used for any blocking or anything and all. This will just is used to do live monitoring, and these data from these tool will be used in threat intelligence or in mitigating the steps or in taking mitigation steps and all. We will use the logs. Okay, so actually it is an agent based one where each and every device will be having the agent installed, and that will forward the logs. What are all the device? IDS, IPS, firewall, switch, router. Okay, no, it is not possible to have an agent in switch router, but we will be having it in the security devices in firewall and IDS and IPS for sure. Okay, then the agents will forward the logs. Okay, and the listener and collector will be available in the the master machine where it collects the logs, forwarded logs. Okay, then it will do process it. So we'll have the sensors in the agent machine for packet capturing and traffic flow data also. So that will collect the data and it will give us. Now, okay, it gave us. So what we will do next? It gave the data. What we'll do next? Log aggregation means what? Multiple log formats will be there. Okay, so we have to do log aggregation, and we have to do correlation, facilitation of the search. For example, if I'm quickly searching into the site, the SIM works in the background like that. So it will get logs from the firewall, it will get logs from the IDS, IPS. So irrespective with the vendor support, irrespective with the design and all, it will have multiple log formats. Okay, so for correlation, so how I'm going to do normalize the field, what field here to find out the indicators of compromise. Okay, what is the behavior and what kind of traffic it is, where it is coming from. Okay, type, what type it is. So all these are all field. So it needs to normalize those fields. For that, it does log aggregation with time synchronization also. When it happened, all these timestamps. Okay, then we go for analysis. So in the correlation relating to the security data and threat intelligence, it will give the alerting of the indicators of compromise. Means something is happening in your network. Okay, if I do DOS attack, simply sync flood attack, I'm sending sync flood attack. So what is this sync flood attack? I will send multiple packets of sync packets. So when I send this in huge numbers, what happens? The IDS will detect it, IPS will detect it, it will try to block it. Okay, so we will be collecting, the same tool will be collecting the data from there, and it will help us to go for the analysis, and it will show us there are lots of sync packets in flow. Without having proper completion of TCP three-way handshake, we are getting only sync packets. So it will definitely create an alert. So that will indicate, that is what called as indicators of compromise here. Okay, then it will do verify with the basic rules we have. Okay, and of course it uses machine learning also these days. Then it will check with the user and entity behavior analytics, that what we really have in the baseline according to the user, according to the parameters, is it really the same one or not? So if it is, it will just ignore it. Otherwise, it will create the proper alert. Then with machine interpretation of natural language, emotion of AI, all these are getting, like these days, these are getting inside or implemented with the same tools. Okay, to make it more perfect, to make it automated. That's what we are moving towards. And of course, we will be having it the sooner, but that will also need human intervention. There is actually one common term available. We cannot go for full automation. Even if we go for full automation, we'll have lots of false positives. Okay, so definitely we'll face that. Got it? And what is really happening in the sentiment analysis? Okay, sometimes it is extremely difficult for the machine to compare with the context, with the parameters. Okay, so that is why we have to implement the machine language or the AI. Okay, for it, like it needs human intervention. We will give data to it, so but it will get automated. So it will get converted into machine formats. Then it will get interpreted with the data that logs that are collecting. Then it will do analyze. Okay, instead of human being doing, just an extra intelligence will get added to. Okay, then we have this orchestration, automation, response from the data, what we need to do, where we need to push it. Okay, are we going to make a report? Okay, or what's the next step? Okay, everything. Are we going to get a whole volume of alerts that has been created to somewhere, to any publicly available threat intelligence platform, or do we replay these data to IPS? Okay, maybe you can have like this, before the data reach to IPS, you can collect the data from IDS and firewall, then you can monitor it and you can place it to IPS, but that will not work because it will be a huge lengthy process. So it will have lots of losses, and it is not possible, but maybe you can think in that way for replying the network. Okay, when you have the live monitoring in the middle, yeah, you can implement when you make it quick, so it is possible with automation and response. Okay,
didn't quite get the last point.
I'm saying that when we have too much traffics, okay, when we have too much traffics, data will get, or the logs will get generated, and we have to respond to it, okay, in a proper manner. Okay, so everything is done, analysis done, everything is done. What we will do last, okay, so we can integrate the same tools with any other platforms, okay, for our needs, and what needs, on what basis we're going to use. I can just simply leave it. If I feel that traffics are coming, but that's ignorable, okay, because I have a load balancer, it won't affect, so everything is getting taken care of, or I will just alert the team me to take care of that particular incident. Okay, I can do that by response, or I can give the data to a threat intelligence platform. Okay, maybe the same one, this particular one. Okay, Alien Vault one. So I can give it to them. Okay, they have community, so they can use it later. Okay, so how are we going to give response for the traffic that you're receiving? Got it? Then
Yeah, thank you.
Then we have file manipulation. What is this? So I told you, like, we will discuss about the file integrity, file manipulation in the last two slides, right? Actually, this slide will help you to check the file manipulation in a manual method. They just added at last for additional knowledge. In here, you can use cat. Yes, that view contains one or more files. Head and tail will help you to view the top 10 lines and the bottom 10 lines. Okay, and logger will help you to write the system logs. Okay, so these three things will help you to check out what's happening with the file. If you feel that file has been manipulated, you can go for it. These are all for Linux. For Windows, you can see just by the properties. So the size has been increased or not. Check out the file, open it, and all this. And of course, if you feel that logs are too much, so what I'm going to do? So I can go for regular expression and grep. Okay, the grep command, which is in Linux, is used to search the files or grab something. I have a word list. I showed you the Rocky.txt that contains 1 crore passwords. Okay, I just want to know really that is there any password that is Sam. Okay, that is with Sam. So I can use this grep to grab that particular SAM string only. So that will help me. So what they are showing in here, it is just a simple command. It will just grab the IP address access log from the access log file, the particular IP address. If I suspect that a particular IP is having established connection and I feel like something is going on with my network, I can try it. If when someone is trying in all kind of Linux distribution, not only the host, you can try in any, if for example, if your firewall is running in the Linux kernel and the Linux distribution, you can try it. The grep will work in all the Linux distribution. Okay, and this series of IP address, it will check all the three IP addresses, two IP addresses actually, 1.1 and 1.3. Okay, so this is very helpful in getting the files checked for any manipulation, for the integrity and all. So yes, integrity we can use hashes also. Integrity you can use hashes also. That's how it's done automatically. If you do it manually, you have to do in this method. Okay, so these are all the techniques that we need to use in implementing network security appliances. And the next one we will be discussing about the protocols and all, but we have the lab to complete. Intrusion detection system. I think we have completed the secure network design. We have to do configuring a firewall, intrusion detection system, and network addressing service comes with the next. What we're going to do here, simply we're going to configure a firewall in Linux, because we all know in Windows how to do. Just simply create a firewall rule and add the port or the service to block. But now we're going to try it in the IP tables. So we have the penetration testing machine here. So we are going to block port number 80, inbound ports specifically. So we will create the firewall rules, but before that we're just starting the Apache server web service. When you have this command executed, means you are enabling your Apache server, so you can use your IP address anywhere in the local network. So if whatever you have it in your local network in the port number 80, so they can access it. Okay, so it is running, it's active, great. Then now we'll just open Linux machine. They're trying to access the port. Normally it runs in port number 80. In case if you want to change it, you have to go to Apache configuration file. There is a file in the sorry, I'm typing the URL in here. Okay, there is a file in the Kali or the Linux distribution where you can change the configuration. If you're deploying any WordPress site, if you're deploying any kind of site in your local server and your htaccess file, everything, you have to install the Apache and all. Apache is okay, but if you're really deploying any site and all, you'll be needing database and all. So I'm not sure like how many people of you like worked really with the Linux environment in deploying any applications or something. Have you tried before? So we will just open browser and we will try to open it. Maybe if you try, like if you want to know how it will look like, I can give you a hint, like I can give you another topic for you to learn apart from the security plus. Try solving hack the boxes and try solving the vulnerable machines. And once you know that how the box and all working, try to make one. If you know how to make the vulnerable machines, okay, I work on that, and we are making lots of boxes, and you can also solve. I will just give you boxes that is made by me, vulnerable machines, okay, especially for hacking. Okay, now we have this website that is accessible from the Linux machine. Now we'll go to Linux machine to start configuring so that no one can access the particular site or something. That's what we're going to do. So what we're going to do, drop any inbound HTTP connections by the port number 80. So the command that we're going to use is IP tables and I input, okay, -p TCP, and with the destination port. See, this particular rule just blocks every IP. If you are creating one for a particular IP, you can have the source IP and the destination IP, that kind of rule. Okay, so we just drop it. Did I make a spelling mistake? Yes. Okay, it's done. Now we'll display the IP table rules. Is it created or not? Yes, it is created. Only one rule has been added in here. Great. Okay, so they're just making the output or putting the file in another unnecessary, but still for task purpose, just do it. Okay, now we'll go to LX. And if you try to reload, yes, I think we got successfully blocked the site. It is keep on loading. Site is not reachable. Okay, great. We successfully completed how to configure very simply. Now we'll be displaying the IP table log files. If we've tried to reach it, right? So there may be logs, right? So we will insert new IP table rule in here for the port number 80. The connection for the port number 80 are getting to accept the connection. So let's see. They are trying to do that, and they will try to reconnect it to check it's working. No issues. So we'll simply remove it, but they are adding a new rule to accept it. You can, if you don't want, you can remove it. If you have, only one rule, you can remove it. No issues. Okay. Great. Enable the logging. Okay. We haven't enabled it earlier. Okay, so see, when you add the rules, it goes from the top to bottom only. The access control list, right? It will go from top to bottom. So whenever you add a new rule, it goes to the top. So it will definitely log whatever if we do anything. So we'll just move to Linux machine. Let's try it once again. It's not loading. Yes, it worked now. Great. Now we'll just go to Kali machine to check the logs. Okay, so check the logs from this particular directory. Gonna logs. Okay, and this pipe symbol will just add the previous command input to the next one, and the grep port number 80, because we blocked the port number 80, right? If someone tries to access that, so the log will be storing the port number. So I'm just grepping that port number 80 from the kernel file, and from the least 10 lines, means the last 10 lines, sorry. Yes, we have the source IP address information. Try to access it. Okay, so we got the information in here from the source IP address information, port, protocols it used, port number, everything. Got it? So you can easily check out who tried to access it, from where they tried to access it, everything. Just locally we're trying, but if you have it in the public network, the same method will be following with the access control list. Okay, but there the IPs will be different and the configuration will be a bit different with the IP address that you're going to add. Okay, so that's a different one. Okay, so this is what assisted lab for configuring like the firewall, and how you can configure a firewall in Linux, how you can add rules, how you can block a port, how you can accept a port, or how you can create logs, then how you can inspect it. Okay, the next one we have is configuring IDS. Okay, so Windows Defender Firewall with advanced security. If you just search start button Windows Defender, you will get the inbound rules and outbound rules. Okay, so all the inbound rules, outbound rules that my Skype, my Steam, and my FIFA account, everything is using inbound rules and outbound rules. Okay, if you are specifically want to add, create a new rule. Okay, and which one you want to block, program or port or anything. You want to block port, click on port. What protocol that you want to try, you are trying to block it, TCP, and you can specify a remote port here, or you can specify all remotes, or you can simply allow one later. That also you can do. Block all the remote ports and allow only one port, or you can specifically add one here. It's like this. I don't want to add. I will just add 1337. Okay. And allow the connection if it is secure. If someone is using IP security, then it will allow it, or otherwise block the connection. Okay, when does this apply? In all the places, in all the network, domain, private, public network, whatever. I can create this for test. That's it. Okay, I need to enable this rule. Okay, it is already enabled, it's blocked. These are all allowed ones. If I want to disable it, I can disable it. Okay, that's how you create rule with Windows Defender. Windows Defender Firewall. Let me delete this rule. I don't want. Now we're going to do configuring an intrusion detection system. Okay, we have a very big diagram in here. The lab topology we have multiple routers in the middle, and two networks. We have two different networks, and penetration testing machine is here, and that belongs to a different network. And the Windows machine, MS machine, and the domain controller machine are in the different network. The interface has no IP address. We need to understand this. Okay, they've added the SIM in here with this interface. Great. And this interface has no IP address. It is used as a monitoring sensor only. So vlocal SIM1 Ethernet interface. Okay. So simply like we have a network, and the traffic goes from different internet ISPs, okay, virtual ISPs actually, and switches. And when we try to attack it, we have to get into two SIMs. One is placed outside the network, one is inside the network, but just outside the workstations. Okay, now we'll try to do so. Remote network packet will get redirected at the VMs on the vlocal LANs routed through this different three routers. Okay, so we have to go here, then we have to go here, then we have to touch the SIM, then we have to go here, then we have to touch another SIM if we want to get in touch or get in contact with the DC1. Okay, so that's a very big architecture, but in lab, let's see what we have, how we're going to do it. So let's sign into the SIM machine. They have had it. We understood the objective. So simply we will be attacking the DC1, or we will try to get in touch with the DC domain controller and the MS machine, which is in a separate network, and our traffic goes through three routers and through two SIM also in the middle. Okay. Okay, so which one will choose here? Ethernet 1. Okay.
And the question is, what is this machine?
This machine, yes. This machine is specially configured for security incident event management. The same tool that we've discussed, right? Especially for that. It is a distribution, especially we have it for the SIM management. It means the security incident event. We have the Kibana, Squirt, and this SGUL. So these are all the collection of free software components for network security monitoring. Okay. For Kali, we use it for penetration testing, right? For Ubuntu, we use it for server deployment, and we have Red Hat Linux. So according to that, we have the, for SIM purpose, we have the separate operating system. That is Onion, this Onion, Security Onion. But don't get confused with the TAR, not the one. Okay, sure, it has multiple sensors, alert IDs, date, Source port, destination IP. Okay. Number of alerts are already more. How many alerts we have? Do we have anything at the bottom? Let me scroll it. Minimum we have to count it. Okay. Not huge, but in real time, we will have large amount of traffic. We have to check one by one. SOC analysts do that only regularly. They have QRadar, they have Splunk, multiple tools are there. They'll be doing again and again. Only that they will do. They will raise ticket and they will forward it to the other team. With Splunk, yeah, I didn't give you the example for the SIM tools, right? So this is one of the SIM distribution we have. We were using that, but tool base is also there. Alien Vault is one. I've shown you Alien Vault, and you can use QRadar and you can use Splunk. Okay, these are all different tools available for the SIM activity. Okay. So check it's really reachable or not. With count 10 packets, it is reachable. We're getting the reply. -C is for 10 counts of packet. So it is we're getting the reply, means it is reachable. Now we'll just go for SIM machine. See, they have this router, everything, or like they simulated the environment. They see when you open different labs, you will have that related machines you can see here. I think yesterday or day before yesterday, we were seeing only 2 machines here according to the lab exercise. So whenever you open a particular lab, they create this virtual environment specially for that. So might be they might have like created in a particular that different environment or different networks. Okay. This is what console is. We can see lots of event messages, potential SSH scanning or what, Nmap OS detection. See, when you do scanning, when you do Nmap scanning, when you do anything, so you will have all the notifications, Trojan downloaded, right? Web server possible, ICMP info ping. Yes, this is what the one we are searching for. Do we have anything else more? ICMP info ping. Yeah, no, only one. So I think this is the one. Okay. Count field, it's only 1, so totally 6. Yes, totally 6. Actually, I've shared only 6 packets, right? I stopped it in the middle. I cleared the screen. Bad habit. Okay. So yeah, we can see that it is done by 6 times, and it is having a different IP also. Okay, is that it? See, okay, they have separated it like to avoid our confusion. They've mentioned like the source IP in the diagram itself. That is why. So it belongs to a different IP address, the PT machine, and it is getting the IP from there, and the destination IP is here. That is this machine, where it received 6 ping packets. So simply you'll get the alerts like this when you have. So it is collecting the data from the router, okay? And whenever you try to reach this machine, it is collecting from the SIM. You have a separate sensor placed in the middle. It is inspecting that also. Okay, great. So we're going to configure the IDS rules now. Okay, so we browsed the IDS successfully. Now let's configure the SGU. So in here, we're going to configure this machine. I don't like to use this Vim text editor. Vim is a very powerful text editor and very tough one also to use. No problem. We'll just run this time. Okay. ETC, NSM. You can use Nano. You can use LeafPad if your Linux distribution is having multiple text editor is there. Disable SID. Yes, they've mentioned you may use Nano also. Okay. This is a new file we just added in this particular directory. That is the directory for our particular tool SGO. Okay, so go to move the cursor at the end of the insert mode. Okay, here, click it, type. Okay, it's typed. Now, one value for the SID you recorded earlier. I haven't recorded. Do we need the information from here? We couldn't see any SIDs here. Which SID they were talking about? Okay, we missed one step actually. Sorry. Okay, so in here, show packet data. Yes, this is what the ID is. ID is this. Show the rule also. Yes. Okay. I missed it. I've seen it now. Yeah, this is the one SID. Let me open Notepad or Nano or something. I will write it there. Two 100 366. Okay, we will use it. No, not here. Here. Okay. Two 100 366. Okay. Started 366. Okay. And then we exit it. So exiting command is this: you have to press escape, okay, and you have to press colon WQ and hit enter. Okay, and when you type on something, you have to click on the panel, okay, in the terminal, then you have to type something, or if it is not working, you have to press I for insert. That is in Vim. Okay, press I and you can type. When Nano, it will just quickly you can open and you can use it. I haven't opened this Vim. I've opened it sudo, right? But why it's not opening? It's showing that error. It should not show. This is why I don't like. Not working. Yes, it worked. Okay. So I used with sudo only. It was showing like not able to save it. No, so this time I'll just go with Nano. Okay. Last time I opened the same file, right? It was not showing anything. Okay. And here we'll type it. I think it was not properly showing in Vim. Okay, now save it. Okay, but still, so that's why it was not able to pull that particular file. It was showing an error that there is no such file. Okay, spelling mistake. Great, we've created the rule in here, and sudo rule update. Okay, done. Now go to ET machine. Ping. This time only 4 count. We've added it. We've added one rule. Let's see, and maybe we will check the IDs now. They just shown how to configure the rule, but nothing much. We have just added the rule for that ICMP packet that it is receiving, that is ping packet that it is receiving. But you use the SID for that, and we have created it at the top, but they didn't mention like what we're going to do. Okay, what we will do actually when we do create alerts, right? If we go for see, okay, it is using snort in the background only. Okay, so when we do create alerts, when we do create rules with this kind of pinging request or anything, it will automatically create alert. Okay, I think we have created the alert once again. We have already got the rule once again already. In you can see in here ICMP info ping, that where it comes from the external network to any of the home network. Okay, for the ICMP protocol. So this is what the rule is. Okay, so up to here I type 8. Okay, so we have just created another rule, but in a different manner that we have created. Okay, no issues. Now let's check the IDs. Okay, in map, really it is showing something, or we misunderstood what. Let's check. Switch to sim. Yes, scan suspicious. It is showing clearly. We are getting the scan, suspicious scan inbound, potential VNC scanning. So with the Nmap, when we do it, it is working fine from that particular IP address. That's good. Great. Okay. Nothing. We just scanned it and we just checked it is working fine or not. Testing the ideas. Okay. And here they've mentioned one more command, and we haven't discussed about this in our theory or anywhere. Okay. I haven't shown you this. So we will see this. It is not according to your sim or anything. It is just a command we use for attacking. What kind of attacking is? It is a DOS attack. They've added just for task purpose, but it is an attack. Now let's see hping 3. Maybe we can use this attack later also in the next exercise. -D 120. I will explain what all these arguments are. Okay. Okay, so we are using hping tool to craft package with the 1000 count and with the data of 120 against the port number 80 from a random source port. There is no need to we don't have to worry about the random source port, and we are attacking on the target. So actually in flood mode, sorry, I missed this comment, in the flood mode. So when you have this flood mode attached with it, this one carries out the DOS attack without expecting any replies from the other machine. Okay, this is what called as DOS attack is. Okay, so when you do it, definitely it is using this -s actually indicates sync. This W64, it's not needed. You don't have to use it also. And if you have 1000 count and 120 data, it is just a normal packet flow. It won't be a DOS flow. It won't affect the other machine effectively. Okay, and DOS attack won't happen just like in matter of seconds or minutes. It needs to we need to carry out this for like days, weeks and months also without getting undetected. So that big attacks will create or will crash the whole server. So how many count you have to use? You have to use count like when you use this much amount of data and count, right, with the command hping, so it will consume their bandwidth and their packet size and the resources, everything. Ultimately it leads to crashing. Okay, unless if they don't have load balancer. Okay, now we'll try to really that same one machine has got triggered or what they mentioned it will get triggered. Yes, we have lots of packets, spammers packets. It was continuously flowing. I think 100,000 packets will be there. It was not having 1,000. Still I think it is continuing. So we're getting few. Great. We're getting this also get alerted. So I think this particular tool has been configured everything with all kind of rules. It can detect Nmap, it can detect hping, it can detect the DOS attack and normal pinging activity also. That's good. But if you are getting a new ideas, and if your vendor, make sure like you ask your vendor that what kind of access control list or what kind of security list that he will be adding it from their side. If everything is in your hands, then it is not a good choice of choosing that particular ideas. So make sure your vendor gives all the access control list in prior. Your job is to just change only the IP address or the network information. Okay, so simply all the rules will be carrying the ideas. All the rules will be carrying. When you do place an IDS, you're considering the internal network, right? So whatever the traffic that comes from external network, you can add rules like that. Only to have a specific IP. That's what I've shown you the rule in the SQL tool also. Okay, so it's not getting affected. We need to see some changes. Maybe if not, we have to like leave it for some time. Okay, so we're gonna do something. PowerShell. We just attacked this machine only, the IP address that we carried out the DOS attack 0.2, right? That belongs to MS1. So now we'll just check the net stat. Is there any connection that's going on? I haven't done this as an administrator. From the DC machine, foreign addresses DC machine, but we haven't done from there. I don't think so. There is no proper package that's coming in here. Like it should reach. Nothing in here. We'll do it again, I think. Okay. Now we'll do because I stopped it, right? So we'll go to MS1, right? Then we will check now. Let's start again. So we just simply deploy the firewall, and we've created IDS when we have deploy the rule, and we verified with ICMP flooding attack, pinging, and Nmap also. It is able to capture all the traffic, and we are doing a DOS attack in here. And I think I should stop attacking. I don't think they will be having that much weak for this 1,000 packets, 1,000 count of packets. So is it because of DOS attack? Okay, let me do it again. If it still persists, then the DOS attack is successful. We'll get to know from that. Yes, it is with something to do with the DOS attack. But it's not like maybe they on purpose they've configured it in that way to see some real result. But for 1,000 count and all, it will not work in your real time. Even you can try attacking from your computer, your Kali Linux machine to your Windows machine. It will easily handle it. Maybe you can face some speed issues, and it may like hang a little bit. But I don't think so that it will crash abruptly like that it did now. Now it's working. Okay, so that's what we have in here with the intrusion detection system and all. They've added a DOS attack also for additional one. Great.